Beginning in the object context of Houdini, I'm going to drop down a geometry node. I'm going to rename it, calling it first iteration. Diving inside, I can then type out test geometry head. Zooming in to this head by pressing F while hovering over the display port, I can now switch off the UV texture by clicking the checker box in the display panel. And then right-clicking on the work lights, I can set the lighting to dome light. Next, right-clicking on the scene lights, I want to turn on ambient occlusion. Hitting D while hovering over the viewport will open up display options, in which I can go to the background tab and change the color scheme to dark gray. Lastly, I want to hit V, the viewport, and I'm going to use the radial dial to find the view options and move to flat wire shaded. All the polygons will appear to be faceted. I like this when I have to do group selections. It's easier for me to spot the polygons on various angles while looking at the geometry. Now I'm going to start manipulating the groups that are available within this test geometry by adding a group combine. I want to get all of the organs, like the eyes, the mouth, and the nose, put together with the face, so that when I hide this group later, I can look inside the head, and sometimes just it gives a better perspective of the groom if you're not always looking at the face, which is kind of a human nature. In the group name, I'm going to choose face, and I'm going to say equals face, and now union this with additional groups. I can use the drop-down menus to grab individual names, but if I have them memorized, such as eyes, lips, mouth bag, nostrils, I could also choose to just type these names out into the parameter field available. With this new group, or the old group of face redefined, I want to now add a group expand. This node can be used to increase the region that a primitive group covers, or it can be used to also reduce the region by dragging on the step slider. So I should rename my group to the one that I'm working with, which is face, and the base group that I'm starting with is also face. Now dragging on the step slider to the negative direction, as you could see in the viewport, reduces that island of selected polygons. I'm reducing it slightly because I believe that the amount of face selected originally would interfere with where I like my scalp to be drawn out later when I make a scalp group. Now I'm repeating this group expand procedure to work with the neck, which was another group that was included inside of this template head. I'm going to grow the neck group up by a few steps until it reaches the bottom border of the face group, in case I want to hide both the face and the neck, leaving behind the ears and the head, which I'll later on call scalp. If I want to see all the existing groups, I can hit the groups button in the display panel. And right now it is looking at primitive groups, so this is perfect. Dragging the steps up to 2 will increase the neck group just enough to be able to reach that face group that has been reduced and shrunk. Now it's time to create this scalp group, which will be used for spawning hairs later selectively to the region of the head. And to do this, I drop this group node. The group name should be called scalp, and the group type should be set to primitives. If I hover over the viewport and hit space 4, I can get a side profile. Then using the selection icon in the base group, I can now enter a state where I can interactively drag out a portion of polygons that I want to keep, or primitives. I prefer to have the settings for selection on as lasso instead of box. And also, I'm going to turn off the select visible only option so that I select polygons that are on both sides of the head. I now begin dragging out, making sure I intersect each primitive or polygon perfectly, ignoring the other ones that are selected by the lasso on the left side, because as I continue to work towards the right, the lasso will not envelop those primitives. So now I'm going to go around the ear and then work my way down to the nape and work my way back up to create sort of a loop. All I need to do is follow the instructions of pressing enter when done, which is at the bottom of the screen. Now I'm going to create a little option in my node graph where I can switch the face on off, or rather to switch the scalp on and off by using the visibility node. Here I want to select a group that has been made, which is going to be the scalp, and the action will be to hide primitives and then to grab the non-selected primitives when I hit the apply to option. The purpose of this is to just get the scalp shown. Now with the switch node wired in and the other option coming from the group create directly above. I can change the select input to either 0 or 1 and see the scalp isolated. Now I'm going to break this scalp up into smaller regions. I want a top scalp, I want the side scalp working around from the side to the back of the head, and I also want a front scalp. So again, using the viewport with the orthogonal right view still selected. I want to grab the selection icon, and I'm going to look at the scalp, which has been isolated using that switch node, and draw out a region that's just for the top. I'm still continuing to work with the lasso mode for the selection and selecting primitives on both sides of the camera. Hitting enter to complete this selection, I now have the top scalp. From here, I can remove that selection from the overall scalp to get the side scalp instead of dragging out a lasso selection again. To do that, I'm going to use the group combine node, but instead of union, I'm going to use the operator subtract. The group name will be side scalp, which is brand new, and it's going to be equal to the overall scalp subtract the top scalp. Now to get the front scalp selected, I'm going to continue the node graph with a group node. And again, the group type will still be primitives, and I will name it front scalp. If I switch on the display group button in the viewport panel, I could see the previously made primitive groups. This might be helpful if I'm having trouble remembering where the top scalp was, as I want my front scalp to be a smaller region of the top scalp. Now, using that selection icon again in the base group area, I can use the lasso mode to grab the front, let's say 3 columns of primitives, and then press enter when I'm completely done with that. Now I want to update the top scalp to not include the front scalp. So with a group combine node, I can take that already made top scalp for the group name and set it to equal itself, subtract the front scalp. Great. Now with all of those groups selected, I can leave the right orthogonal view by hitting space 1 to return to perspective view. And I can now move around in the viewport to see my groups and see the scalp. Now I quickly want to make another visibility option where I can see the scalp without the neck and the face, but this will now include the ears. Dropping another visibility node, I'm going to select for the group face and neck. If I want to test this, I need to go back to that first switch node and select input number 1 so that everything is visible at that level to see what the new visibility node does for removing the face and the neck. Sure enough, it works just fine. I can see the ears have been included and a lower part of the nape. So I will bring in another switch node similar to before and then wire in the visibility and the group combine. And switching the inputs from 0 to 1, I can see all of the head and then just the scalp with the ears. This now completes one step of preparing for the groom. So I will now select all of the nodes used to create this solution and drag out a box, hit Shift-O to create a network box, and then call it Step 1 Grouping. Since it is the first time I've made this solution, because it's iteration 1, I'm going to give it a color. As I create solutions, I like to give the network boxes a color, and if I return to a project at a later time and create a new solution, I like to have the old network boxes just as gray, and everything new made on the next iteration with a color. So naturally, I'll give this a color to start off and continue working. Now it's time to start generating some hair. From that switch node, I will drop down a hair gen node, wiring the output into the skin input, which is the first dot at the top of the hair gen. And then the group to scatter on surface will be the top scalp and the front scalp. I need to increase the density by more than 1,000, so I'll jump up to 100,000. This groom will slick back, but I still need just that region to grow this length of hair and have this control. I like to have a thickness at 300 micron, so if 1 is a meter and 2 zeros after the decimal with a 1 is millimeter. If I add one more 0 and a 3, I have 300 micron or 0.3 millimeter. I want the value of the last node in my hair profile curve to have a 0.1. I never like to end guides with absolute 0 so that they come to a sharp tip. I want the hair guides to always have a little bit of thickness even to the end. Now that my grouping has been done, it's safe to use a blast node. This blast node is going to be to isolate the scalp, and I'm going to attempt to create a solution using advection. For this, I have to create a volume. So the scalp will be the underside of the volume that I create, and using a poly extrude, I can push out from the scalp almost like a bicycle helmet. And just remember to check the box that says output back to have a shell that is completely watertight. The distance, I could try anything to get started, 0.1. That's pretty far, so I'll adjust it down to say 0.04. This is a good size shell to do our advection inside of. It's also useful to have the back group that's created from this poly extrude. I'm going to need that to drive the advection as a region that velocity should diverge away from. Now I'm going to create a group of primitives in the back of the head where I want velocity to diverge towards. Hitting space 2 in the viewport brings me to the front, which I can hit space 2 again to see the back. And creating a group node, I can give it any name, but it has to be primitives. So I'll call it exit. And now clicking the selection icon and making sure that the select visible only is toggled on, I can drag out a region using the lasso, pressing enter when I'm done. And this is going to be the target for hairs that are following velocity to aim towards as they advect through the. To begin advecting, I'm going to use the volume velocity from surface. Another really handy node, similar in name, is volume velocity from curves, which is great for animal groom, but this one is volume velocity from surface. Now, I need to change the voxel size. This is very important. If the voxels are too large, there won't be enough resolution in order for the hairs to curve properly around the surface of the head. We could see here that a voxel size of 0.1 is too large. I'm going to go an order of magnitude down, 0.01. This looks good, but this is still too large. At the bottom right of the display port, I see that I have 21,000 voxels, and it just jumped up to 7.8 million. Now I'm going to start creating some divergence groups. Hitting the plus button twice in the surface divergence section, I can take a group type, being primitives, select my exit, and then the other group type I can select as extrude back. Now the logic here is that you want the velocity to move away from the extrude back, so I'm going to use a -1 as the divergence to repel. Now dropping a guide advect node, I can take the guides that have been grown from the hair gen into the first input, and the second output of the hair gen can go into the second input of guide advect for the skin. And now the output of volume velocity from surface goes into the fourth input of guide advect. And there we have it. The hairs that were once standing straight up are now all working towards that one region in the back. I'm going to change the operation from constrained advection to fill velocity field. This gives a smoother look, but it does add segment length into the operation. So I should turn this off by clicking on the segment mode and changing it to keep input segment count. Now all the hairs continuously have the same, still have the same amount of segments, which was set in the hair generation. This keeps them looking smooth and less blocky. The hair is looking very slick into one region and coming to a point. To change things up, I'm going to add a guide process node with the first operator, the operation being set length. I can see that there's one guide that's sticking straight off into nowhere. I'm going to fix this by first of all setting the maximum length of all the guides. That hair will continue to exist and it'll be hidden, as it was most likely a very short one that just needed to be culled. With the maximum length method being set to cut or extend, the hairs will be reduced in length so that I don't have this point where they all reach together. Changing the length from 0.1 to 0.05, I can see a difference already. And there's a lot of hairs that are also not reaching the back anymore. This is fine for the look that I'm trying to get. Now in the operations, if I hit the plus button, I can also add onto it a set lift. After some experimentation previous to this recording, I found that full lift value works just fine, and reducing the blend is how I want to control the overall look. Setting lift to 1 and then dragging the slider or typing out a blend of 0.1 gives a nice messy look of the hair being pulled to the back. The hairs are no longer looking like they are grouped into a point at the back of the head. To further add some natural look, I'm going to add a hair clump node. Hair clump always drops in with a clump size by default too large for the template head. So the first thing I need to do is reduce the clump size so that I can get more clumps showing up. To do this, I add a 0 after the decimal, and now I want to work within this region. I also find that the clump profile is coming to a point at the end, so I'm going to delete that one point in the profile so that no clump comes to a tip, to a pointy tip, and then just drag out the other point number to the far right of the profile. I could still see a lot of pinching near the roots of each clump. To solve this, I'm going to continue to manipulate my clump profile. Next, under the fractal clumping tab, I'm going to change the iterations from 1 to 2. This will make clumps within clumps, which will break up the forms a little bit, while still keeping the larger clump region by the root, but will also help fill in the groom just slightly. This is now another solution to the hair groom, so I'm going to give it a network box and call it Step 2 Advection. Again, the color green to match the color of the previous step network box. Now, returning to the test geometry template head, I want to get ready to try another little trick when working with the fade, which is going to be on the side of the head. But first, I'm going to need a volume. It's noticed that with a number of these groom nodes, there's always an input for VDB or volume. You have to make that volume. To do this with the head, I have an empty neck at the bottom, so I need the polyfill node, and then I can select the fill mode to triangle fan. From there, I can add a VDB from polygons. Again, the voxel size matters. So instead of 0.1, I'll add a 0 after the decimal to 0.01. Now I can see a likeness of the face and the head. This will be the volume that I can use for the inputs later on when working with groom nodes. Dragging a wire out from the final switch node in the grouping section, I'm going to add a hair gen node once again. This time, the group that I'm going to scatter on surface is going to be the side scalp. As always, I need to increase the density, and I'm going to change the appearance in the Attributes and Appearance tab to match the guides of the other parts of the groom. Wiring the VDB from polygons into the fourth input, which is the volumes, will affect the hair generation. But to really get this to work, I'm going to take that output of the VDB from polygon and wire it into some later used grooms. As we can see, the outputs of the hair gen is only 2 outputs, being the guides and the skin, which means that the VDB information will be lost if we work further down in our node tree. Now, connecting this hair gen to a guide initialize, we're going to use a wind to push the hairs in a direction. This is similar to advection, but we don't need a volume to work with inside, and we are not working with voxels. However, in order to have the hairs not pass through the ears, I need the volume to enter into that third input, the skin VDB input. Once connecting this to the guide initialize, I can clearly see the difference in the hairs bending around that surface and avoiding it altogether. Now for my wind direction, I don't want nearly a strong Z, so I'm going to reduce that so that the hairs grow almost straight down, with just a little bit of Z proportion for the wind direction, say putting it at a negative 0.5. Now I want to create a solution to work with the groom left and right, top to bottom, and front to back. To do this, I need a point VOP node, and I'm going to use a bounding box delta node. This will look over all the points, specifically these guides, which are placed in space from left to right and top to bottom, front to back. And then I'm going to try to selectively add an attribute based on that location, which I can later feed into a guide process to control hair length, but yet control it with the power of ramps. So adding this attribute VOP node, I can dive in, and the VOP that I will need is called relative to bounding box. The input will come from the geometry VOP global, and it will be the operator input 1 to go into relative bounding box file. Next, I can take the position output from the global and wire it to the position input of the relative bounding box. And now everything's mapped out. To get individual control over the X, Y, and Z as I add parameters, I'm going to connect this VOP to a vector to float. Now my float values are of the X, Y, and Z for the output of this VOP. Leaving it at the default for the signature of 3D vector, I can now connect a parameter ramp node to each one of these outputs, making sure to give them a different name. The first output controls the X, so I'll change the name inside of the parameters to ramp X. The ramp type cannot be RGB color ramp, and it needs to be a spline ramp. With this ramp parameter node successfully created, I'm going to drag out a copy, but I need to remember to change the name, as there will be a conflict in what it controls for the parameter. Also, the ramp Y needs to be connected to the second float value output of the vector to float. Repeating this process to make a final ramp Z ramp parameter, I'm also going to wire that into the third output of the vector to float. Now I have ramps which remap the outputs of the X, Y, and Z points, which are mapped inside of the relative bounding box of the geometry of that groom. To bring them all back together, I'm going to use a multiply node, such that the idea being if the groom needs to be the same from front to back, the Z could be left ramped at 1, but then if the groom needed to change and fade from short hair at the bottom to long hair at the top, the Y would be controlled to ramp in a linear fashion. Lastly, I'm going to use a bind export to create a new float attribute, which I'm going to name hair length. Jumping out of VOPs and back up to geometry context by hitting U on the keyboard, I can now see that I have this new created attribute in this hair length node, which was an attribute VOP. Wiring this in to a guide process set length for the guides input and connecting the guide initialize skin output into the skin input of the guide process, I can now control the length using the VOP. For this to work, the operation is set length, but the mode needs to be multiply. The scale factor is set to no override, but I'm going to change this to guide attribute, and then the guide attribute in the dropdown is hair length. I can immediately see the difference in the groom. Hairs at the back of the head are shorter, hairs at the bottom are shorter, and hairs at the left side of our viewport on the head are shorter than hairs on the right. Selecting that hair length VOP, I'm going to change the ramp X to be the same throughout all the groom. So instead of a straight ramp, I'm going to change it to a constant instead of linear, and then just set the value to equal 1 all the way across. Dragging out point number 2 from right to left, I can clearly see the hairs growing back in, and now they are symmetrical on the left and right. Likewise, the ramp Z will not need to change the hair length from front to back. So again, I want to fill out the profile to be a solid block, which is a 1 for a value straight from front to back. This can be done by just deleting the first point. Now, using the Y ramp, here's where I'm going to enjoy the control of slowly dialing out the profile curve and watching the hair shorten itself until I get it right to the height that I want, dragging out that 0.1 to say a position of 70 to 80%. And lastly, that second point, instead of it being a value of 1, which is a large length, I'm going to reduce that value down. And this will create that effect of using the clippers to make slightly longer hairs before you blend into the rest of the groom. With this procedural control, I can always go back if I believe the fade of the hairs to be incorrect to match the top portion. But now I have another solution for using VOPs to control hair length. And from the guide initialized, I still have proper hair growth direction around the ears. To see how these two portions of the groom work together, I need to connect a merge node into the node tree. Taking the output of the guide process and the output of the advection hair clump, merging them both into the merge node and putting on the display the view flag to that node, I can see what both of the hairs look like. The fade looks a little bit grown in as it reaches the long hairs at the top, but I'm going to accept this. Now I just need to create a network box around this step 3, which I will name using VOPs. I'm going to prepare to bring in the head geometry so I can see the groom with the rest of the head. Before I do this, I want to add a color node just to change the color of the hair slightly off from what the rest of the geometry will look like. I'm going to pick a color of gray that's a few shades lower than the full white, and then add another merge node, which will connect that color and the output of the switch node from step 1 grouping. And there we have it. Inspecting all around, I can see my groom against my geometry. I can go back at any time to change the density of these hairs. I'm going to leave them as is, and I can clearly see the groom fade working with the longer hairs at the top. To finish this, I'm going to add an output so that whenever this geometry is selected at the object level, it'll always show this final view, no matter where I've left off in the graph with the display flag. And this completes my first iteration. We've made a couple solutions today, but it'll help us build more ideas as we work on our second iteration next time. Thank you for watching.